Hello everyone. Okay, so in this video, we are still kind of moving on with our differentiation rules. But in this video, we're going to be looking at the product and quotient rule. So the product rule is used when we have a product of two functions. So for example, f of x equals x plus 2 times 3x squared plus 4. So we could expand the brackets here and then differentiate, but it actually might just be easier to use our product rule. So our product rule is like this. So we usually use product rule if we're kind of multiplying two algebraic terms together. So if uv, what you do is you identify one of the terms as u, the other as v, and then the derivative is going to equal to u times the derivative of v plus v times the derivative of u. And this is in your log tables. So here is one now. So I'm going to say u is equal to 2x squared plus 1, and v is going to be equal to 5x minus 3. So du dx is going to be equal to 4x. dv dx is going to be equal to 5. Then it's just u times dv dx, so 2x squared plus 1 times 5 plus v times du dx is 5x minus 3 times 4x, which is equal to 10x squared plus 5, 20x minus 12x, what's 20x squared I should say. And my final answer here then is going to be 30x squared minus 12x plus 5. And that is the first derivative of this here. Right? So let's just look at some exam questions here. Yes. So this is from 2006. So differentiate root x times x plus 2 with respect to x. So u is going to be equal to root x. v is going to be equal to x plus 2. du dx is going to be equal to, so remember root x can be written as x to the power of a half. The derivative is going to be 1/2 times x to the power of a half minus 1, which is minus a half. And dv dx is going to be equal to just 1. So du dx is going to be equal to 1/2 times 1 over x to the power of a half, which is root x, 1 over 2 root x. Right, let's get started. So u times dv, so it's just root x times 1. Well, that's just going to be root x plus v times du dx. That's going to be x plus 2 times 1 over 2 root x. And so look, that's just going to be root x plus 2 over 2 root x. No funny business there. Right, and there we go. We differentiate using the product rule. One more here is from 1969. Differentiate with respect to x. So 1 minus x squared times 1 minus x squared. So u is going to be equal to 1 minus x squared. v is equal to 1 minus x squared. du dx is equal to minus 2x. And dv x is going to be equal to 1 goes to 0, minus x goes to minus 1, and minus x squared is going to go to minus 2x. So u times dv dx, so 1 minus x squared times minus 1 minus 2x plus v times du dx. That's going to be 1 times minus 1 minus 1, 1 times minus 2x is minus 2x, plus x squared plus 2x cubed, minus 2x plus 2x squared plus 2x cubed, and my final answer then is going to be 4x cubed. 4x cubed plus 3x squared minus 4x minus 1. There is my first derivative of that function there. Stunning. So let's move on now to the quotient rule. So the quotient rule is used when we're dividing two functions. So if I have a kind of a polynomial on top and a polynomial on bottom. So this one's a bit more complicated. This is in your log tables. So your numerator is u, your denominator is v. It's going to be v times du dx minus u times dv dx all over v squared. So it's going to be v times the derivative of u minus u times the derivative of v all over v squared. So let's have a look here. Differentiate y equals x squared minus x. U is equal to x squared minus 4. V is equal to 3x minus 2. Du dx is going to be equal to 2x. dv dx is going to be equal to 3. 3x goes to 3 minus 2 goes to 0. So that is going to be 3x minus 2. So the formula, let's use right up here. The v times du dx, which is 2x, minus u, which is x squared minus 4, times dv dx, which is 3, all over v squared. My top here is going to be 6x squared minus 4x minus 3x squared plus 12 all over 3x minus 2 squared. And that is going to be 3x squared minus 4x plus 12 all over 3x minus 2 squared. I don't think we can simplify this any further. That is it done. Yeah, that's the quotient row. Right, so it's very easy. You just need to know which one's your u, which one is your v. So let's just look at some exam questions for this now. For 2013, differentiate 5x over x plus 4 with respect to x. So u is equal to 5x, du equal to 5, v is equal to x plus 4, dv dx is going to be equal to 1. That is going to be x plus 4 times 5 minus 5x times 1 all over v squared, which is just going to be equal to 5x plus 20 minus 5x. Well, that's just going to be 20 on top over x plus 4 squared. There's my first derivative there. Next one, differentiate x squared minus 1 over x squared plus 1. So u is equal to x squared minus 1. V is equal to x squared plus 1. So du dx is equal to 2x. dv dx is going to be equal to 2x. That is going to be x squared plus 1 times 2x minus x squared minus 1 x all over x squared plus 1 squared. So multiply the top here, I have 2x cubed plus 2x minus 2x cubed. So 2 minus 2x. Yeah, and then plus 2x all over x squared plus 1 squared. So that'll be equal to 2x cubed, cancel out minus 2x cubed. It's going to be 4x over x squared plus 1 squared. There is my derivative there. Then finally, this one from 1971. U is going to equal to 2. V is going to equal to x root x. Well, du dx is going to be equal to 0. dv dx is going to be equal to, well, x root x can be the same as x times x to the power of a half, which is x to the power of 3 over 2. That's going to be 3 over 2x. 3 over 2 minus 1 is just a half. That's just going to be 3 root x all over 2. So the v times du dx, well, that's going to be times by 0, stunning, minus u times this, 3 root x all over 2, all over v squared, which is x to the power of 3 root 2 squared, which will actually be equal to x to the power 3. That's going to be equal to minus 3 root x all over x cubed. That's my answer there using my quotient rule. So that is your product and quotient rule. So hopefully it was some help to you guys. And I'll catch you guys later. Bye.